Namaskar, sir.
नमस्कार इंदु जी.
Ranjit, sir, can we start the session?
Yes, ma'am.
Okay. I welcome expert of this session, Professor Akshay Dwivedi. After a wonderful
Good
first
morning, ma'am.
session by sir, uh, this is matter of pleasure to me again to give introduction of sir to the participant who were not in the first session. Professor Dwivedi did PhD from IIT Roorkee in advanced manufacturing processes. He did his MTech from IIT Roorkee and BTech from Jivaji University. Professor have areas of interest as advanced manufacturing processes, non-traditional micro machining, metal matrix composites, primary and secondary processing of MMC, quality management, QFT for service sector. Professor Divedi awarded many times for best research paper and for best teacher as well. Sir worked and working on seven sponsored projects from various organizations like DST, MHRD, CSIR, etc. Professor authored and edited 58 various book chapters and conference proceedings. Sir supervised 18 PhDs and having more than 100 research publications in reputed international journals and conferences. He is a member of many professional society and conducted many conferences as well. I again welcome you, sir, and we are seeking from blessing for blessing from you, sir.
Thank you, Dr. Indu, for your kind words. Now, dear participants, if you recall, the first interaction that we had was about design thinking and how we go ahead with that particular design thinking. And in fact, on that particular day, we talked about development of a particular product. Now, today, what I will be doing is I will be giving you sort of an overview of few more products. And in those, I will be discussing about that if you have clearly identified the stakeholders' requirements, which are there for a particular product, then you will be in a better position to develop a product in a way where it can actually serve the purpose. So, just to give you sort of a maybe refresher kind of a thing. Uh, During the first lecture, we talked about development of this particular device, which was adaptive feedback controlled hydrodissection device. And this particular device is used for hydrodissection during cleft palate repair kind of in surgeries. Now, for this particular thing, there were, of course, certain customer requirements. And when I say customer, I basically mean to say that there are certain stakeholders. And with those particular stakeholder requirements, once you understand them, you are in a better position to develop a particular product. Now, I assume that all of you have a different kind of a background, maybe the specialization that you have are again from different streams, and maybe from your own environment, you have a different understanding about different products or different things that are in and around you. And today's discussion, I'll be talking about few more products that what we have developed over a period of time. Not all of them, but of course some of them. And in doing so, how customer requirements come into existence, how do you identify them, and is there a proper way to actually understand them? So basically, when we start understanding this particular thing, I will be taking you to this particular slide again, which is basically the first step of design thinking, the empathize mode, where you try to develop some innovation so that you can actually do something change, some change that is in good sense. Basically, if you have to create a meaningful innovation, you need to know your users and care about their lives. This implies that stakeholder mapping is something which is very important. Again, what stakeholders actually wish to intend, you need to understand those particular things in a proper manner. Most important thing is there can be certain requirements which can be said readily, where people can express those, and certain requirements can be where people may not express those. Maybe they do not have that kind of a technical understanding what you have as a developer or a designer. So in those particular cases, you need to have an approach how to actually go ahead with this particular thing. So to answer to this particular query is in fact to reach at some particular level where that level can be a starting point. I will be talking about a particular approach which is named as quality function deployment. And by this particular approach, basically you have a wonderful way how you can document all those particular spoken and unspoken requirements, and basically then you build sort of a matrix which is referred as the QFD matrix, also known as house of quality. And in doing so, you are at a level where you are in a much more comfortable position to empathize with what your customer actually wants them. Now, once you do that, then only you will be able to bring in the technical things, the engineering characteristics that have to be there in a particular product. So before I start that particular topic, I will be showing few of products that we had developed, of course, with multiple contributions from some of my students. And these particular developments have actually come up in a way where their results are far better as compared to any of the existing product in market. Far better in terms of maybe the performance, or maybe on the terms of cost, or maybe in terms of the overall use. So I'll be showing you a few products. uh, Dr. Indu has already mentioned that I have an inclination towards advanced manufacturing, so some of those products are basically from that particular area. I also work in healthcare, so yeah, that particular hydrodissection device is one such product. Recently, we developed a particular low-cost portable mechanical ventilator. So again, that is one particular product which evolved at a very fast pace. And the majority of these particular things are industry ready. So when I say industry ready, basically this implies that these particular products are ready to be deployed in industry. In fact, some of those particular products are already being used by industry. So let me give you sort of a overview of some of those particular products, and then we can start with the actual topic, which is quality function deployment. That we will be understanding how to go and realize the customer requirements, who are our those particular customers, which are very important, and then from those particular customer requirements, how to develop a particular outcome. So to start the actual thing, are you able to see the slide? So this is slide number 2. Is there?
Yes.
All right. So, most of the work that I do is basically on development of microfluidic devices. Now, when I say microfluidic devices, these are basically devices which I have come up with multiple names. One such wonderful name is named as lab on a chip. So basically, let's say if there are certain scenarios where you have to check multiple pathogens, and in doing so, you need to react those particular pathogens by certain reactants, and then finally there will be a chemical reaction, and you can check with that particular chemical reaction whether this particular pathogen exists or not, or maybe in certain case what is that particular percentage concentration of this particular pathogen in a particular sample, which can basically lead to a case where if let's say there is a disease to be diagnosed, that particular disease can be diagnosed in a quicker and faster manner. Now, idea behind development of these lab on chip devices is that can we make these particular lab on chip devices small in size, basically portable, and if we can make them portable, basically there will be a lesser requirement of reagent, and this implies there will be lesser operational cost that will be involved in pathogen testing. Most important thing is if things are smaller, they are easier to handle, and this implies you can easily take away these particular things to maybe even remote locations. So, for example, if I have to just give you one simple thing, just for the sake of understanding what we actually wish to do here is, you must have seen those particular test strips which are readily available as sort of a counter kind of a test strip for pregnancy detection. So you just drop a few liquids of human urine, and that particular test strip basically reveals that okay, whether this particular lady is pregnant or not. Similar to that particular thing, when we have, let's say, issue with respect to, let's say, H1N1, and we want to detect that particular thing. So it is actually possible to get certain sample, and that from that particular sample, you do some kind of a chemical reaction, and on device itself, you can see what is the overall outcome. So with that particular thing, when lab on chip device comes in, basically you can conduct multiple tests on one single device. And for doing so, you need to create this particular lab on a chip. And for that particular specific purpose, manufacturing comes in picture. Now, when we have this kind of a scenario, what we have is, let's say, if you have some kind of a surface, and on that particular surface, you need to create certain holes, and from those particular holes there will be certain channels from which fluid will be flowing. So channels can be straight, they can be a multiple case where they can have certain serpentines. In certain cases the shape of this particular channel can be a spiral one. Now each channel will be having a particular cross section, and that particular cross section can be as per the requirement. Cross section can be a perfect rectangular one, it can have some kind of a tapered section, it can have maybe sort of a U section. In certain cases, you can make it as a complete V. Now, the thing is, what the dimensions we are talking here are basically in terms of micro domain. So basically, I am talking in dimensions in terms of micrometer. So maybe width can be 100 micrometer. The depth that you have for this particular channel can be 50 micrometer. And just to give you sort of a reference, when I say 100 micrometer, what it actually means, if I have to give you sort of a live example, the hair on your head is having an average diameter of 100 micrometer. We are talking about creating a particular channel that is that small. So in case if you have to develop these kind of things on materials which are again difficult to machine, for example glass, by the way, glass is one of easily available material which is very cheap. It is transparent, it does not react chemically with multiple environmental things, and that is why it is a wonderful material that can be used for these lab on a chip devices. So if you have to create, let's say, a channel with a typical kind of a shape, which can be spiral, which can be serpentine, which can be maybe a combination of straight spiral and serpentines, in that particular case, again, when dimension is very small, there are certain issues which comes into picture. So just to start with these things, I have given you sort of a requirement that the customer has. And what are those particular requirements? First requirement come from material. Material has to be non-reactive. Second, it has to be transparent. Third, it has to be cheap. But when I bring this particular requirement to, let's say, somebody from manufacturing domain, the manufacturing people will be troubled by these kind of requirements. Because if you have to create something in micro size on material like glass, there are certain issues. Glass is hard and brittle. Now, in that particular case, when you use, let's say, any kind of a conventional machining approach, things become very difficult. There can be a suggestion from, let's say, someone who says, okay, glass is easily to melt. You can make a particular mold, and with that particular mold, you can create whatever shape that you wish to make. But the issue here is when we talk in dimensions of micrometers, in that particular case, to get this particular glass shaped in that particular specific size, the problems are huge. They are many. So those particular molding approaches can not actually help here. So is it possible to create a particular process where that particular process can create micro features, and that too with the kind of precision that are required, which can create, let's say, dimensions which are as per the requirement, which can have, let's say, sort of a taper angle, which is properly controlled and then properly delivered on that particular device? Answer for this particular thing is there are not many processes which are available, but of course there are few which even exist right now. So one such process is named as laser beam machining. I hope you have heard about laser. Yes or no? Heard about what laser is? Have you heard about laser or not?
Yes, sir, definitely.
Yes, sir.
All right. So maybe those people who have no background with respect to manufacturing, even they have learnt about this particular laser, and laser is light amplification by simulated emission of radiation. And herein what happens is there will be light, which is basically photons, and those particular photons will be made to strike on a particular surface, and when those particular photons strike on the surface in a coherent beam of light, they are able to create temperatures in order of something around 8,000, 12,000 degrees centigrade. And this particular temperature is sufficient to melt any kind of an engineering material which comes for, let's say, this particular specific purpose of a microfluidic device. But the issue is, when we talk about laser operating systems, these particular systems are quite expensive in nature. A typical laser processing system or a laser machining system would cost something around 50 lakhs plus. In fact, quite good systems, they can even go in worth of crores. So, is it actually a worthwhile decision to go for that kind of a system which is prohibitively expensive? Now here I am bringing customer requirements. Now customer wants here, or the stakeholder wants here, basically a process which can be economically viable, which can create all those particular shapes that are desired, so that the capital cost, the operational cost should not be too much. Because if those particular costs are too much, the final cost of product will be again very high. Most importantly, whatever that this particular process does, this particular process should be simple. If you recall, during the first interaction that we had while developing this particular hydro dissection device, I said designs have to be simple. In fact, the most complicated designs are simplest. By why they are complicated? They are complicated because there is enough background information that goes into them. But for the user, it should be easy to use. It should be simplest to use. In fact, user should have no problem in interacting with that particular product. And when I say interacting, it is basically using that particular product. So considering this basic requirement of development of microfluidic devices, we actually started working for development of multiple processes. And over a period of time, for maybe last 10, 11 years of my existence in, let's say, a proper research domain, we have developed more than 30 odd processes, where multiple processes have also been evolved as different process variants. And the reason for development of so many things, yes.
Sir, I think your slides are hanged somewhere.
No, 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 no. I am not showing anything. All right.
It's on first slide only.
It is only first slide.
Okay,
All
sir.
right. Okay.
Okay,
I
sir.
will show you. I will show you a few things. Don't worry.
Yes,
Okay.
sir. Okay, sir.
Now, so where was I? Yeah. So over a period of time, it was realized that each process, when you develop, there will be certain more inputs that are needed. Maybe certain cases, customer will say that, okay, this is okay, but we need something more. So many a times you interact with multiple energies to develop certain process variants, and then finally you have a particular process which can give amazing results. And if that particular process is simple enough, it is economical, industry would be happy to use that particular product. So mind it, whenever we develop a particular process, or in where we develop a particular product, most important requirement is to understand the customer's wish, and wishes which are expressed, wishes which are not expressed, still you have to take account of all of them. So with that, we have developed multiple things. My major research area in which I had worked under advanced manufacturing is basically electrochemical discharge machining. If you do some sort of a small Google search on electrochemical discharge machining and just write my name in front of that, you will get multiple pages which talk about this particular thing and basically contribution of our team in this particular specific area. In fact, I can comfortably say that we have the best results worldwide for this particular specific thing. Now, here I will show you few processes which evolved over a period of time, and then I will be coming to the quality function deployment part. So, here I have my first process, which was basically the original process on which we worked, and this particular process is named as grinding assisted electrochemical discharge machining. So the idea here in this particular process is that you need a particular process which can work on conductive as well as non-conductive materials, conductive as well as non-conductive one. And you need to have a particular process where this particular process can create micro features. So that particular micro domain machining is something which is required. Now, for this particular specific thing, conventional machining processes, for example, maybe a lathe or maybe a mill or a drill, they are unable to work on materials like glass. In fact, they are not able to do something, anything, in fact, on materials like ceramics. And if you, let's say, choose those particular processes to work on glass or ceramic kind of thing, yeah, maybe they will be creating certain damage, but that particular damage will result in a work material which is unusable. I want something to have, let's say, dimensions of 100 micrometer, one particular feature. So maybe if there is a channel that has to be created, wherein width of this particular channel is 100 micrometer, and the depth of this particular channel is, let's say, desired as, let's say, 70 micrometer, the conventional machining doesn't help here. Now, in case if somebody says, okay, I do not want this particular channel to have a straight wall, in fact, we need some kind of a taper. And that particular taper is, let's say, 2 degree per micrometer. So in that particular case, again, conventional machining cannot do that particular part. So if for those particular scenarios, unconventional machining comes into existence. And one wonderful process from this particular domain is electrochemical discharge machining. Now, uh, there is a wonderful gentleman. His name is Professor Rolf Wuthridge. He developed this particular process, and he has worked extensively on this particular thing. He right now works at Concordia University in Canada, and with his work, a substantial result actually started coming up. And it was realized by the research community that yes, this particular process has that particular capability to fulfill the requirement which are there for micro machining domain. But the issue here is, when you work with this particular process and when, let's say, you continue working with this particular process for some time, a passivation layer comes into picture. So I will be showing you a small video, and let's say, no, I think don't think that video is available. I will be highlighting that particular thing what I wish to mention from this particular same figure. So here what you have is, you have a particular work material which is glass, and over this particular work material you have a tool, and this particular tool is basically of a solid cylindrical kind of a thing, and this particular tool has been given sort of a tapering section. Now, you dip this particular entire thing into an electrolyte, apply certain potential difference by means of a power supply, and as you go on increasing the potential difference, traditional hydrolysis begins, which is basically dissociation of water into hydrogen and oxygen. Now, idea which in this particular process is that hydrogen will be evolved at this particular tool, which is given a negative polarity. And over a period of time, as you go on continuously increasing the voltage, tool will be enveloped by hydrogen bubbles, and those particular hydrogen bubbles will be creating sort of a insulating film over tool. Now, since you are continuously increasing the voltage, there will be a case where this particular film will be disassociated. In fact, it will be sort of breaking its dielectric strength. And from that particular point, certain sparks will be immersed. And you can see those particular sparks here in my figure. Now, when these sparks come out, they create certain temperature, and with that particular temperature, material reaches up to a point where it melts. That particular temperature is implies higher than the melting point of the work material. So you go on continuously working with this particular process, and finally you are able to create some kind of a damage. And if damage is in, let's say, that particular zone where that damage is creating the feature that is desired, you say that yes, the process is working and you are getting desired material removal. Now the issue is, when we continue with this particular process, we have liquid here, and this liquid is electrolyte. Now, when I say, let's say, electrolyte, one example for electrolyte is
Excuse me, sir.
NaOH. Yes.
Sir, the slide is not moving.
because I am working on only one slide. Right now,
Yes,
it is
sir,
slide
if
number.
you show the ECDM process or by the picture, it will be more clear to the participants.
I don't want to explain those particular things. Because then it will be a talk on electrochemical discharge machining. I don't want to do that particular part.
Okay.
Okay, this is not a course on advanced manufacturing.
Okay, sir. Okay,
Okay,
okay.
I am just trying to highlight that there are certain issues and we have to understand those particular issues. Okay,
Okay, sir.
okay. So, here, what we have is we have this particular electrolyte, and this electrolyte is, let's say, NaOH. So, what you do is you have a liquid, which is water, you add certain salt, which is NaOH, in it, and as soon as, let's say, initial sparks come in, this particular spark will be creating thermal energy, which will be evaporating water out from this particular thing. So that particular zone near the tool, this particular zone will be having maximum rise in temperature. And this rise of temperature will be evaporating the water part, only salt will be remaining. End result, you have a particular scenario where for a particular time being, there is excess of salt, and this basically alters the performance of process. In certain cases, certain sludge comes out during this particular sparking kind of a thing, and that also creates something which is mentioned as passivation layer. So, as you start working with the process, initially it works fine, but very soon this particular passive layer comes into picture due to certain issues where maybe electrolyte is evaporated or there is excess of salt concentration, and with that the process basically stops or it provides sort of inconsistent results. Now, do we have a problem? Have we identified what are those particular requirements? The requirements are you need to have consistency in the process. Now, with those particular things, can you provide a particular solution? The solution here in this particular case is I have this particular tool, and over this particular tool, my film envelopes. And with that particular film enveloping, I will be getting my spark discharges. Now, with those particular sparks, passive layer is now going to come into picture. So, is it possible to actually provide, let's say, a scenario where I can use a tool wherein tool is coated by means of certain abrasives? And while this particular process is working, I give rotation to this particular tool so that these abrasives abrade the work material. And while they are doing this particular thing, they are also providing certain agitation in the electrolyte. And if that particular scenario is happening, basically my electrolyte is getting replenished. In fact, I am getting fresh electrolyte into that particular zone. So if we add, let's say, grinding action, which is basically a mechanical action to the electrochemical discharge machining, we can do something about that particular passivation layer. Now, if somebody wants to know about more details for this particular thing, I will simply request, please search electrochemical discharge machining in my name. You will find multiple publications in this particular regard. But yes, there was an issue and there is a solution that was provided. Now, taking to this particular thing wherein you add abrasives over the tool, you get certain good results. Now, those particular results have to be quantified, in fact, in a way wherein basically you get certain good things from it. So, just to give you sort of a understanding that okay, if you have to visually see these particular things wherein you have some kind of a proof of what you mention, so in that particular case, let us focus on these two oscilloscope images. The first one is with respect to tool, wherein we are using an abrasive coated tool. And the second oscilloscope is image with respect to a smooth tool, which is normal electrochemical discharge machining, no coating provided here. Now, here the oscilloscope image basically talks about voltage versus time. So basically here on my x-axis, I have my time, and on my y-axis, I have my voltage. So if I consider, let's say, this particular zone, and if I compare this particular zone with what I get with respect to electrochemical discharge machining, you can find that there are certain peaks of voltages that you can identify, which are quite less as compared to what ECDM with conventional tool or a smooth tool is doing. So idea here is, if I am removing that particular passivation layer, I am getting better consistency into that particular process. Some examples of this particular process are maybe certain microchannels. Here the dimension which are mentioned are quite high, but of course this particular process can work and it can produce dimension which are quite less, even in terms of 50 micrometer, 100 micrometer, those kind of things. And you can see the kind of cross section that has been created by this particular tool. Now, okay, this is a wonderful process. You were able to remove the passivation layer. Now what? So the thing here is, in this particular process, it was identified that whenever we work with discharges, these particular discharges are able to provide consistent results only up to a depth of 300 micrometer. In fact, for this particular process, it has been realized that up to 300 micrometer depth, in fact, I should use this particular range, 200 to 300 micrometer depth. The process works in discharge regime, wherein discharges basically create entire kind of a damage that is there. But as you go beyond this particular depth, this means when you are penetrating inside the work material after 300 micrometer, you reach at a particular zone wherein hydrodynamic regime comes into picture. Now, these are two technical things for some of you, but if I have to give you a very simple kind of an understanding, up to 300 micrometer depth, discharges are acting, which is basically creating sort of consistent discharges. Consistent discharges implies we will be getting good material removal and we will be getting quite good accuracy of the machine feature. But as I go beyond 300 micrometer, hydrodynamic regime starts, and that gives me inconsistency in machining. And with that particular inconsistency, what is going to happen? The kind of output that we'll be getting is quite less. So, what is the customer requirement here in this particular case? Is it possible to prolong the discharge regime beyond 300 micrometer depth? To do that, certain engineering characteristics needs to be identified. What needs to be done? So here in this particular case, what we did is we provided something which is named as titrated flow. So what you see here is you see a particular tool wherein this particular tool is having a particular taper, and electrolyte flows along the walls of this particular tool while it is moving from top to down. So basically, in earlier case, you were having this entire tool dipped into the electrolyte. Now we have removed that particular entire thing. In fact, we are providing drop by drop flow of electrolyte over this particular tool. You can see this particular tool and an enlarged figure for this particular thing, which shows direction of electrolyte flow. What is the end result? The end result is, in earlier cases, people were facing difficulty to go more deeper than 300 micrometer depth. Some were having results of 400 micrometer, some were having maximum 500 micrometer. After that, this particular process was not serving the intended purpose. What you see here in terms of a figure, when we go with this kind of an approach, you see a cross-sectional view of a machined hole wherein the depth is something around 1350 micrometer. And this is basically created from this particular same tool. To see what happens during the exact process, I have given sort of a comparison between the results which are already existing and between the results what we get from this particular process. You can identify in terms of penetration rate. Earlier cases, it was something around 6.25 micrometers per second. Very good figure was with respect to 30 micrometer per second, which was again given by Wutrich. But this particular process actually gives you a much higher penetration rate, 45 micrometer per second. What it implies, one thing is the discharge regime has extended. Second, what it implies, we have a particular process which can give you good outcomes. So the discharge regime is extended. Now, Another thing which comes in, okay, we studied about that particular grinding assisted electrochemical discharge machining, wherein certain abrasives were coated on the tool and those particular abrasives were removing the passive layer. Uh, is this a good approach? Answer for this particular thing is it is a good approach, but of course, this particular approach has certain issues as well. Now, whenever you coat, let's say, abrasive particle on an electrically conductive tool, abrasive is, let's say, silicon carbide. Silicon carbide will not be having that kind of a conductivity as, let's say, a stainless steel tool or a copper tool. Basically, it will be acting as a non-conductor, insulator kind of a thing. So in that particular case, electrical properties of that particular tool will be changing according to the kind of abrasive that we are having. So is it possible to still do something so that your passivation layer can be removed and you do not change electrical properties of that particular tool? More or less, is it possible to actually avoid that particular coating procedure? Because coating on a particular tool which is very small in dimension will be additional process and that will be costing money, because you want to develop a particular process for industry where the process can be cheap, where industry can actually use that particular process. You need to provide them easier solutions. So one thing that was identified that okay, the customer requirement is electrically conductivity of this particular tool should not change. We should not go for those particular processes wherein we are increasing the cost of manufacturing a tool. So let us have a process or develop certain things like that, wherein the overall capital cost as well as operational cost they both remain minimum, and still you are able to get good outcomes. The idea came up into development of something which is named as tool roughening system for electrochemical discharge machining process. Now, how we actually started with this particular thing? So for that, what we have is we had a particular simple electric discharge machining process. Now, what this particular process is, basically in this particular thing, you have a tool and you have a work. So tool is given negative polarity usually, work is given a positive polarity. You keep dielectric medium, which is basically a liquid. One example is kerosene between the tool and work. And here in this particular case, you provide potential difference. As you go on working with the process, there will be sparks which will be coming into action, and those particular sparks will be creating temperatures again in order of 8,000 to 12,000 degrees centigrade, similar to what was happening during the laser machining. Now, we use this particular same process, reconfigured it in a way where this can serve our purpose of tool roughening. How to do that? So if you look at this particular figure, what we have is here we have the tool for electrochemical discharge machining. This means right now we are using that particular tool as a work, and we put a brush kind of a electrode which is acting as tool for EDM. Okay. When potential difference is applied, we provide rotation to this particular tool, and with that particular rotation, sparks create sort of a texture on the tool. The end result is here we have distribution of electric field intensity on this particular tool, which has now been textured. This is one particular topographic view of the rough tool. What is the end result? The end result here is we have two cases. One is with respect to smooth tool, and second one is with respect to rough tool. All other parameters remaining same. When certain experiment was conducted, it was identified that the kind of depth that is achieved with rough tool is far more as compared to what you get with respect to a smooth tool. Additionally, the kind of flatness which is available with rough tool is far better as compared to what you get with a smooth tool. Now, this is fulfilling certain customer requirements. Answer is yes. Are you spending too much amount of money in development of such kind of a texture tool? Answer for this particular thing is no. Here, this particular wire brush is a cheap thing, and working on a EDM has got very less cost in terms of its operations. So more or less, the cost of fabricating this kind of a texture tool is not too expensive. And the best part here is, if you can create this kind of a texture, you can actually create textured surface on the work material. In earlier case, whenever we talked about a particular surface which has to be there for a microchannel or maybe some kind of a serpentine shape or a spiral shape, in those cases we were not able to get these kind of textures. Now if you can create this particular texture, this is a wonderful thing, because if you have these kind of textures, it will be easier to deposit reagent over these particular textures, and this implies these particular shapes can actually give wonderful results and practical outcomes. Going ahead. So, all right, you have a wonderful process. Is it possible to create with this particular process wherein you can create maybe multiple slits or micro slits? And in that particular scenario, yeah, the variant was changed into a particular way, wherein now we have put the tool as sort of a wire tool. And with that particular wire tool, certain polarity is provided to this particular tool, and work is fed from the sides. So here you can see my work material is coming from one particular side. Now, as we work with conventional kind of an electrochemical discharge machining, that same procedure comes here. Only thing is, manipulator is moving this particular work so that it is being fed into the tool. And while that particular thing is happening, it is creating sort of a slit in the work material. Now, here, the tool texturing system that we developed earlier for usual electrochemical discharge machining, we use that particular same thing to develop sort of a roughness or in fact a texture on a wire surface. End result, there is something which was required. That particular thing was channelization of electrical energy, so it becomes distributed over the entire tool surface. That particular thing has been taken from a previous study, and with this particular study, with proper orientation of manipulator, you can actually create multiple splits. By the way, whenever you develop a particular product or whenever you develop a particular process, it is very important to make people know about that particular thing. So one way is, if you find out that it has got a commercial aspect, please go and file a patent. If you find out that this particular thing can provide an incremental enhancement in knowledge, please go and write a particular good article on that particular part. So yeah, for each and everything, some quantifiable outcome should be there. Now, few more things which now comes in uh, is it possible to go in a way wherein you can reduce the thickness of gas film that gets developed on that particular tool while the process is working, and especially when we are talking with respect to the electrochemical discharge machining. Now, in that particular case, ultrasonic machining is another process wherein you provide certain ultrasonic vibration to the tool, and with that particular vibration, you are able to remove material. So, is it possible to provide, let's say, ultrasonic vibration to electrochemical discharge, wherein those particular vibrations can provide assistance to discharge mechanism here in the process? Why do you want to make this particular film thin? What is the reason? It was realized that if film thickness is too more, in fact, this is what customer desires. They want this particular film to be thinnest as possible. And the reason for this particular thing is, whenever you have certain sparks, those particular sparks should be high frequency sparks. This implies more sparks in less number of time, and those particular sparks should be sufficient enough to create certain temperature so that your work material can actually melt. So what you need is, you need basically high frequency sparking. Simultaneously, you also need a high intensity of each and every individual spark. And if possible, that particular intensity should be more or less uniform throughout the process. So let's say, if you carefully look at this very small oscilloscope image which I have here, you will identify that frequency of sparking is quite high, and all of those particular sparks, in fact majority of them, are having same kind of an intensity. So to do so, when you apply ultrasonic vibration on the tool, the film actually changes its shape. In fact, if you look here, I have my nascent tool, which is of 600 micrometer diameter. When you work with simple ultra electrochemical discharge machining, the film thickness is 1050 micrometer. When you add ultrasonic vibration to it, at 5% power rating, this implies, let's say if you have a 500-watt machine and you are using just 5% of that particular thing, that is only 50 watt, your film is getting reduced from 1050 to 840 micrometer. At 10%, it is reduced to 780 micrometer, and so on. Now, if you have thinner films, this implies you can have higher frequency. Higher frequency implies more number of sparks. And if you can also identify those particular scenarios where spark intensity is also more or less same, you will be having consistency in the process. End result, you will be having a process which can serve all those particular intended things, and that is basically an industrially relevant process. All right, so this is the last thing which I am going to discuss, and then I will be coming straight away to that particular quality function deployment thing. So, if you recall, when we started, I gave you one particular figure which said that possible depth by electrochemical discharge machining with titrated flow was something around 1350 micrometer. All right. Now, here, what was identified is, okay, if you provide by drop that particular electrolyte, is it possible that you can actually quantify the amount of electrolyte that evaporates during, let's say, one spark? And then you should supply that same quantity of electrolyte. If you can do that, that is going to provide a far better consistency. The question that came up with respect to, let's say, stakeholder requirement is, can you go much deeper? Can you go deeper than this particular 1350 micrometer? And if you can do that particular thing, that is going to be quite good. In fact, now then you have a process which is basically economical, which is able to do multiple things, and that will fulfill all of those particular customer requirements. So to do so, we identified that yes, the electrolyte needs to be replenished, and that particular replenishment has to be in line with the amount of electrolyte that gets evaporated. So process which developed over a period of time was referred now as pressurized flow electrochemical discharge machining. And if you look at the depth of a hole which has been made by this particular process, this particular depth has reached something around 2500 micrometer. In fact, it is just double than what the previous value that we had. In fact, we have done substantial work on this particular thing. We have this particular can even go more than 5 millimeters now, no problem at all. So when we talk about all of those particular things, we need to actually understand that whether it is possible to have a particular way so that we can actually identify customer requirements, and that too in a way where we fulfill those requirements so that everybody is happy. To do that, do we have a process? Now, whatever talk that I delivered right now, with that particular talk, it was sort of a hurried explanation that, okay, customer requirement understanding is something which is very important. But with that particular hurried kind of a thing, do you really feel that is it possible to ask every time when you are doing something to reach to that particular specific customer, in fact approach industry that, okay, I am working on a particular process, what kind of a requirement you have, or I am working on a particular product development, what kind of a requirement you have? Is it actually possible? Answer for this particular thing is, of course it is possible. Now in that particular case, one thing which comes in is, see, one particular product will have multiple users. And is it actually possible to approach all of those particular users wherein you are able to clearly understand their requirements, both spoken as well as unspoken? Answer for this particular question is no, it is very difficult. I will give you one, in fact, very simple example. Now, let's say if you have to buy maybe a television in your household, all right? So let us assume who are those particular members in a particular household. Maybe you have a particular case scenario where it is a nuclear family, there is a husband and a wife, and maybe let's say two kids. Okay. Now, in this particular case, if they have to buy a television, the requirements of the customers here means husband, wife, and kids, they may differ. Let us have a case where maybe husband and wife both are working, all right, and let's say they are living in sort of an apartment kind of a building. The kids are maybe in that particular age group of maybe 12 to 14 years, or maybe 12 to 16 years, so slightly to moving towards the adolescent range. Now, in this particular case, husband may have a requirement that he wants a particular television which is in line with the current standard size which is right now coming in the market. So right now that particular size varies from maybe 43 to 55 inches. Okay. Now, we are not considering this particular scenario where somebody wants to buy a 85-inch television. Maybe 43 to 55 is a good number. Now, the next thing that this particular husband may feel that okay, it should be of a good price, maybe something around 50,000 rupees. Okay. So, what are those particular companies where these particular companies can provide this kind of a television? The answer for this is okay, maybe company like OnePlus, maybe cheaper versions of Samsung, they can actually work. Maybe for Sony, there is one what 7400 kind of a model which is coming into this particular range. But of course, when this particular gentleman went through sort of a online review of all those particular televisions, he also identified that there are companies like MI, there are companies like Hisense, there are companies like Thomson, which are providing a similar kind of a thing at much lesser price. So husband says, okay, I will be looking at 4-star ratings, and from that I will be picking one particular television, and let us go with that. He suggests this particular thing to the wife. Wife says, to hell with your money part. We are living in an apartment. Even if I am working in, let's say, a particular company, but still in evening I have to interact with other families in the apartment. And whatever that we do, we will be buying a television which is made only by Sony. And we will be buying a current model, which is basically year 2022 model. And we will be buying the premium range of that particular television. And we will be buying a OLED television. Now, when you compare, let's say, a television with, let's say, QLED technology, and when you compare it with OLED, the price difference is huge. And when you compare, let's say, a television which came up in 2020 and 2021 and 2022, again, the price difference will be huge. So husband's requirements are quite different. Wife requirements are quite different. Maybe the prestige and quality, they are primary things for her. Now talking about the kids. Oh, kids are those particular from that generation which are into maybe watching over the air network or OTT kind of things. They are also in this particular habit of having certain time utilization in terms of playing games. So they want maybe multiple connectivity options. They don't care about whether it is a Sony or a Samsung or a MI or a Hisense. They want a big television set with multiple connectivity options. Now, let's say when a decision has to be taken in this particular case, what should be the criteria? Who is your most important customer? Is the husband most important customer who wants a cheaper one with maybe certain desired specifications? A wife's criteria will be more important, where she wants maybe a best brand and the latest technology. Or the kids who do not really care about the brand, but they just care about the connectivity options and the biggest possible size. The answer to this particular thing is too difficult to find out. The issue is let's say now all of this particular entire family goes to market, visit a particular showroom where they see this particular television, and here in this particular showroom there is a wonderful salesman who, while explaining the features of this particular television that he has in the showroom, gives Bhaviji some special recognition by saying that, okay, Bhaviji, see, this particular model is from 2020, but it is manufactured by Sony, and this is the best possible model even at this particular date. No model which came up in 2021 and 2022 is able to compete with this particular model. This is so good. Hi Sahab, the price is 50,000 rupees. The 2022 model in this particular range would be costing something around 1,10,000 rupees. I think you will be making a very good investment on this particular case. And to kid, this particular salesman says, see, this particular TV has got 3 USB connections, in which one is USB 3. It has got multiple HDMI connections. It has got HDMI 2.1. In fact, this is the only television which has got that particular HDMI 2.1, and this is a great buy. Even if you buy the latest Xbox, you can easily connect this thing to it. Maybe one fine day you decide to buy a sound bar. That particular sound bar can directly be attached to it. In fact, this has got Wi-Fi and all those connectivity options. So what we have is, we have a particular scenario now where customer voices, earlier they were not monolithic, they were diverse. But now we have a particular product where all of these particular customers can be associated with some of the feature of this particular product. So this is only one example. Can you have the same kind of a thing for each and every product, for each and every process? Answer for this particular thing is no. So can we have sort of a way where we can identify those particular customer requirements and maybe have some proper documentation, so that whenever a certain logic or certain decision has to be taken for product development, that particular decision should form a sound base. There has to be a clear logic. To talk with respect to quality function deployment, most important thing is, if a customer gets answer to this particular question, where am I in this particular process, that customer will be most happiest. Now, when I say where am I, this implies whether there is a problem which this particular customer was having and the product solves that, customer is identifying the answer for where am I. If this particular product can actually provide certain features where customer is not able to clearly express them, but if this particular customer gets it, he is getting or she is getting the answer of where am I. So how I am getting benefited from this particular process or a product. If this particular thing can be answered, the idea is great. And this is what we do in quality function deployment. So the idea here is, whenever we talk about quality function deployment target, we have to actually fulfill the customer requirements or the stakeholder requirements in terms of what they want and how the product finally delivers this particular thing. This implies, if you do not use this particular approach and if you do not understand what a customer clearly wants, you may be slightly creative in doing something. For example, here a customer wants a simple swing which can be hanged to a particular tree. What sales have done is they have added another rope to it. What market planning did is they added multiple planks to that particular swing. Engineering wanted to be creative, so they made slightly a different way of tying it. When we talk about with respect to manufacturing, they said, okay, it has to be robust, so load should be beared by 2 branches. So they made here the product which is basically hanging on 2 different branches. Field service wanted a fail-safe kind of a system, so they provided more support on those particular branches. But whether this particular thing is able to serve the customer requirement, answer is no. When we talk about with respect to customer requirements, what customer wants, we want to deliver that particular same thing. Taking this particular journey to how do we do it, I have a simple case. Now, this is a photograph of a car which is named as Ford Taurus. And in fact, this particular car was Motor Trend's Car of the Year for 1986. It was Car and Driver's 10 Best List for 1986. And this is one particular car which actually brought Ford back in the market. Now, if you look at this particular figure, can you appreciate anything good in this particular car? Is it too beautiful? Is it quite flashy? Is it maybe worthwhile? Whether you will be buying this particular car? What is your opinion? Any comments?
Sir,
Yes.
we are still on slide 11, I think. We are not seeing any change.
Slide
Uh,
11.
Electrochemical discharge machining process.
Okay. Can you see the fresh slide?
No, sir.
Okay. Well, what has happened? Now?
Yes, the Ford car photo, na?
Yeah, yeah, yes,
Yes.
yes, yes.
Okay,
Okay.
thank you. Thank you.
So for the previous talk, there was no presentation that was required. So that was basically an extempore which I delivered. Okay.
Okay,
Now,
okay.
now we are talking about quality function deployment. Now, I hope you were able to realize the kind of example that I gave for that particular television.
Yes, sir.
Okay. So the idea here is customer voices are diverse and it is not possible to capture all of those particular voices just by asking questions. In fact, there has to be a particular way where you can document all of those particular customer requirements in a way where those requirements are comprehended in a proper way. And then from them, you will be developing something which can serve as a product or a process where key engineering attributes are clearly mentioned what they need to be. Now, to understand this particular context, I have a figure which is for Ford Taurus, and I said something very good about this particular car. But if you look at this particular car, do you really feel that this is a wonderful product?
No, sir.
No, sir. It looks okay. It looks like a big car, no issues. And of course, the wheels are slightly having a typical different kind of a shape. But this is one particular car which actually brought Ford back into the market. And I'm talking about that particular case when Japanese companies entered into US automobile market. And in those particular case, Japanese companies were creating cars which were comparatively cheaper as compared to what US companies were making. Additionally, these particular cars were lighter in weight, so the mileage that they were delivering was far better to as compared to what was there with respect to any US car maker. Now, Ford was at a particular scenario in those days where they felt that okay, very soon they will be moved out of the market. But they did something, and that particular thing was understanding customer requirements in a proper way. And they came up with this particular model, which is Ford Taurus. Now, what is so great about this particular car? See, first and foremost thing is here you can identify that this particular car has got sort of an aerodynamic shape. So it provides lesser wind resistance. Lesser wind resistance implies lesser vibrations while the car is moving. Second, it also provides better mileage. One very good thing what Ford people did in this particular car is don't laugh at my example. They provided space to keep coffee cup for the driver as well as passengers. US is a big country, and when someone goes from one state to another on a interstate highways, they drive for multiple hours in at one stretch. And courtesy, those people have also got a habit of drinking coffee. So imagine a scenario where you are driving for 5 to 6 hours and you want to have a cup of coffee, you stop during the journey, you took a cup of coffee, and that particular cup is usually in the size of a glass. It is quite big in size. So you cannot drink it in one go. So, okay, the car is moving and you are holding that particular coffee thing in one hand and you are driving. Mind it, if you have to stop at some place or if you have to apply certain sudden brakes, maybe somebody comes in front, where you will keep that particular coffee. Answer for this is nowhere. You may drop it. Ford Taurus provided space for holding coffee cups, both for the passenger and the drivers. Right now, in our cars, we have that particular space available either for a coffee or maybe for a water bottle, those kind of things. But in those days, companies were not providing these kind of facilities. Ford identified this particular thing that, okay, customers have this requirement, and they fulfilled that particular requirement in Taurus. These few things actually made this particular car to be a worthwhile product, and this particular thing was then mentioned as setting a mid 90s benchmark in advanced engineering, safety and comfort. Never has a new Ford car been such a pleasure to drive and ride in. And this was a quote which was given by Britain Daily Mail. So identifying customer requirements and fulfilling them, that is something which is very important. Now, how you can do that? To do that, we will be learning about quality function deployment. And for that, I have a simple figure to explain this particular concept to you. Can you see slide number 25? I do not know whether the slides are changing for you or not.
Yes, sir.
Perfect. So this is what you know as a quality function deployment matrix. It was developed as a methodology in year 1970s by a gentleman named as Yoji Akao. And this particular gentleman was a person from Japanese origin. Yoji Akao identified that there has to be a way wherein customer requirements can be properly documented. Those particular requirements should follow verbatim. Verbatim means word by word, whatever customer says. And that particular thing should provide a way to designers so that they can identify which requirements are more important. So basically, how to prioritize those particular requirements and then find out how technically those requirements can be met. Now, once this particular thing is done, Yoji Akao also wanted that, okay, once you have this particular thing developed as sort of a matrix, this particular matrix should also reveal what is the competition when this particular product that you intend to develop, how it can compete with other products which are there in the market. And let's say if you develop this particular product, what will be the target values that the product has to achieve? Okay, for example, if I say, let's say a car, so target value for this particular car can be mileage. The target value can be car should have a mileage of maybe 25 kilometers per liter, or the target can be maximum speed. So car should be able to achieve maximum speed of, let's say, 200 kilometers an hour. So in that particular case, Yoji Akao developed something which is named as quality function deployment matrix. And when Yoji Akao moved to US from Japan and explained this particular concept to people in US, he wanted to explain this particular concept. And when he showed this particular figure to those people, it was very difficult for them to actually interpret what in Japanese language means to those English speaking people. So what they said is, okay, let us call this particular thing as house. Why? Because this particular matrix looks like a house. So they said, okay, this is a house of quality. Now let us go one by one how this particular houses get developed, how to do that particular thing. So we have certain walls on this particular house, and we have a roof, and then we have a roof on top. Now, I have a better figure for this particular thing. So, when we explore this particular house in individual components, what we have is we go step by step. The first and foremost step is which is not present in this particular house of quality, who are your customers? This implies you need to identify who are your stakeholders. That particular stakeholder identification is something which is very important. So let's say if you are working in any scenario and if you have to identify who are your customers, you can have your own ways to identify that. A simple way to identify those particular customers is using the WH context. Now, what is this WH context? W here is who is the customer. Second W is what this particular customer wants. Third W is why this particular customer wants this particular thing. Fourth W is when this particular customer will be using this particular thing, or what is that particular time at which this particular requirement is needed. The last W is why this particular thing is needed. Now, if you ask these kind of W questions, you reach to a level where H comes into picture, where H is how to fulfill that particular requirement. So this implies if you ask these questions from with respect to any product or any process, you will be basically entering into that empathize mode of design thinking, wherein you will then be relating with that particular customer. So once you identify who are your customers, the next thing that comes in is what do they want? So left hand wall of this particular house of quality is made as the customer needs. So basically, if it is a big matrix, you can identify those particular requirements. Let's say there are 4 requirements or maybe 5 requirements. You identify those particular requirements and into the left hand part. Once you do this particular thing, the next step that is often done is those requirements needs to be prioritized. So let's say if you have a particular product where you have 100 odd customer requirements that have been identified, can you fulfill all of them? Answer for this thing is no. So maybe you need to prioritize which are most important among those. Maybe you need to prioritize 10 of them where those 10 have to be fulfilled whatsoever may happen. Okay. Remaining 90 are also important, but you will be starting with those 10. There is a wonderful saying which has been given by a wonderful quality guru, and that particular saying is named as vital few, trivial many. Vital few, trivial many. So this implies when I talk, let's say, with respect to customer requirements, there are few customer requirements which are vital, remaining are trivial. So when we do that particular prioritization among customer needs, we are focusing on those vitals. Duran later changed this particular thing into a slightly different perspective, where he said vital few, useful many. So few are vital, wherein I have to give them more focus, but others are not so vital, but they are useful. We cannot remove them. So maybe if you have, let's say, 100 requirements and if you prioritize 10 of them, remaining 90 also needs to be done up to some level. Now, once you do that particular part, you reach to at a level where you identify how to fulfill those particular wants. So what a customer desires, the next thing is how to fulfill that particular thing. Here, technical requirements means engineering characteristics, technical descriptors. We are talking with respect to that. For example, let's say if I talk about electrochemical discharge machining, I said at a particular point that 300 micrometer is that particular depth up to which the discharge regime works. Now, customer wants a particular scenario wherein this particular depth has to reach actually to 1350 micrometer. So, when technical descriptor for solving this particular thing comes in, here, electrical conductivity during the process, that particular thing can be one thing. Or the kind of temperature that is being generated during the process, that can be another technical descriptor. Or frequency of discharges that has to be there in the process, that can be another technical descriptor. So there can be a number of technical ways how you can actually fulfill those particular customer requirements. And maybe all of those particular things may not be fulfilling each and every requirement, but of course they are contributing to some of them. That is house. Now let me show you a bigger figure for this particular thing so that things will be slightly in a better understanding to you. Can you see the current slide, which is basically talking about a QFD matrix? Please respond.
Yes, sir.
All right. So what you see here is on left hand side of this particular matrix, I have written few things. For example, IT, AT, INF, IND, ARCH, and so on. And these are basically customer requirements, the watts. Then I have done something which is prioritization of these particular requirements. So basically, these particular requirements have been arranged in a way where most important requirement is appearing at the top. So IT is most important, AT is after that, INF is after that. Then all those particular issues which come under this particular specific domain of problems under IT, they have also been listed in a way where most important one comes at the topmost portion. And then finally you go down. All right. To fulfill those requirements, here are my technical descriptors, how to do that particular part. So when I have this particular scenario, you will identify that there is something written as ergonomical design, concurrent design, design for X, training, maintenance, and so on. Those particular things are actually contributing to the customer requirements. So basically, technically, how you can fulfill those requirements. Now, for example, if you see, let's say, ergonomical design, this particular thing is having a strong relationship between ergonomical design and problem number 11, which is under the domain of IT. And that particular thing is reflected by a symbol, strong relationship. All right. And that symbol has given a beam a weightage of 9. So if you look at, let's say, only up to this particular specific domain, when we are talking about, let's say, only first set of problems under IT, you will identify that ergonomical design is contributing as a strong relationship to majority of the problems, in fact all the problems. However, there is something which is, let's say, redesign, which is contributing as weak relationship to only problem number 11 in the domain of IT. Similarly, reliability is having a weak relationship with problem number 13 in the domain of IT. So this implies if I have to go with, let's say, technical descriptors, and if I have to prioritize which is the most important technical descriptor, from this information, I can readily identify that ergonomical design is having a strong relationship. So basically, there is a logic that now comes in. All right. Now, whenever quality function deployment technique is started, there are certain rules. First and foremost rule is this is not a single person job. This is a team's job. Of course, one person can be a facilitator for this particular thing, but that particular person has to actually interact with multiple people, and with those collective inputs, then only the approach will be revealing good results. If you recall that when we talked about design thinking, I said during ideate step, there has to be multiple ideas. And with those particular multiple ideas, you will be then prioritizing few important ones. And they can be your starting point. In fact, if you recall, I said, if it is 10 ideas, it is good. 50 ideas, better. 100 ideas, far better. 1,000 ideas, excellent. But the thing is, you cannot work with all those 1,000 ideas. That is not possible. So if you have to prioritize few of them, in that particular case, that particular prioritization should be unbiased. Individual opinions may result in bias. And that is why teams are required to do that particular part. Now, when we go to top of this particular thing, what we have is we have certain interrelationships between house. By the way, if I write those particular things, what I have is here I have my what? Here I have my how to do this particular thing. On top, I have house versus house. Now, just to understand what this particular thing is, imagine a particular case where you are designing an automobile and customer requirement is higher mileage and very high acceleration speeds. Now, is it practically possible to have, let's say, a car which can go from 0 to 120 in 3 seconds, and the same time car has to provide a mileage of 50 kilometers a liter? Is it practically possible? Yes or no? Is it practically possible?
No, sir.
Very high acceleration and extremely good mileage. Okay, wonderful. These are contradictory requirements. Simultaneously, this particular customer also wants that car should have minimum possible service frequency requirements. And that minimum possible, according to his or her thing, is car should be serviced only once in 10 years. Now, you want something which has to give very high acceleration. You want basically the rocket speed kind of thing. And you want this particular car to have minimum possible service frequency requirement. This implies system has to be too robust. So these are again contradictory requirements. Now, in this particular case, let me give you a very standard kind of example, which I hope all of you will believe. In India, Maruti Suzuki's cars are considered to be reliable. Do you agree?
Yes, sir.
Perfect. In India, Maruti Suzuki cars are also considered to be those cars which provide quite good mileage. Quite good. For example, if you talk about, let's say, any car like Swift or Desire or those kind of things with all those K10 engines, those cars readily give a mileage of maybe 18 to 20 per kilometer. A car like Baleno, they can claim even up to mileage of 25 kilometers a liter. So can we go with this particular understanding that Maruti cars provide better mileage as compared to other ones? What is your say? What is your opinion? I am waiting. I hope my question was clear. Okay, let us go with the understanding that Maruti cars are considered to be reliable and they are considered to be those cars which provide slightly better mileages compared to maybe other competitors in the market. Now, in terms of, let's say, build quality. Now, when I say build quality, basically I am talking about those particular cases where how heavy the body of this particular car is. Can we consider Maruti cars to be heaviest in the lot? Let's say in comparison with maybe a car by Tata or maybe a car by Mahindra? Answer for this particular thing is no, they are not the heaviest ones. This implies if a customer has a contradictory requirement where they want a car to be very heavy and still in this particular case they want this particular car to provide very good mileage, it needs really some kind of a rocket science. Now, for those kind of scenarios, we need to realize that whenever we talk with respect to technical descriptors, wherein, let's say, one technical descriptor is engine, which is going to provide a better mileage. Another technical descriptor is in that particular case where body is supposed to have a 5-star rating in terms of the overall safety, and it has to be a heavy kind of a build. These things can contradict. So we have a relationship between house and house, wherein, let's say, for one case, when ergonomical design is compared with concurrent design, those things have got a strong relationship. So basically, if you work something with respect to concurrent design, automatically ergonomical design is going to given some kind of an advantage. Now, for those particular cases wherein, let's say, we compare ergonomical design with this particular aspect, which is training, it has a weak relationship. So, if you do something good for training, maybe it is contributing weakly to ergonomical design. Now, I have used values which are 931. I can even use values where it can be from positive 9 to negative 9. So it can be strong positive, it can be medium positive, it can be weak positive, it can be weak negative, it can be medium negative, it can be a strong negative. So these particular responses in terms of certain numbers, they help in taking a proper decision. Now, at end of the day, when you have developed this entire house of quality, which is usually referred as first phase of quality function deployment matrix, you are at a level to start that, okay, which is that particular technical descriptor from where I have to start. Now, for example, when I talk about this particular specific case, I have collected certain values at the last row of this particular QFD matrix. And mind that these particular values have come up from the calculations wherein we are taking in account of the values where strong relationships, weak relationships, or in those cases where a medium relationship is coming into picture. Now, with that, we have certain values. Now, if you look at, let's say, relative weight, which is here on the last part, you will identify that ergonomical design has got a relative weight of 23.6% of the in comparison with all the technical descriptors. This implies if I work only for ergonomical design, I will be actually doing a greater good for majority of the problems. Now, why did I set this particular thing? There is an Italian economist, and the name of that particular economist is Wilfred Pareto. Now, Pareto has given a wonderful principle, and I hope everybody here will be agreeing to that particular thing. What Pareto mentioned is it is 80% of the wealth of society belongs to 20% of the population. So, idea here is rich are few, but they have the maximum wealth of the society. In fact, in India, that particular number can be far lesser than 20%. But that is one kind of an understanding. Okay. So that particular rule is named as 2080 rule given by Pareto. One quality guru, the name which I just now mentioned before few slides, was Joseph Juran. He identified that if we go with this particular concept wherein we have vital few and useful many, the few are 20 and useful are 80. He basically converted this particular thing in saying that there are 20% of problems which are very important. If you do something good for those particular problems, remaining 80 will be automatically taken care of. Or even if not completely taken care of, there will be a great contribution in doing something good for those 80s. So here, if I go with that particular same rule, and when we go with ergonomical design, automatically that particular thing will be doing good for the remaining issues. Maybe not for all, but for maximum of them. This is how quality function deployment actually works. So coming back, step by step, to understand how this particular process actually works, what we have is we have to build a house of quality, and one by one I'll be talking about those particular steps, though as an overview I've given sort of a quick understanding how to make it. If you want more details about this particular specific topic, I will be requesting you to note down a name and name of this particular gentleman who has done extensive work on this particular field is Glenn Mazur, GLEN MAZUR. Just do a small Google search about Glenn Mazur. You will identify that this particular gentleman has worked on development of products, development of softwares, development of processes, multiple things. And it is a wonderful work. If you want, let's say, use some kind of a book reference for learning more about this particular thing, there's a wonderful book which is named as Total Quality Management, and the author of this particular book is Besterfield. So there are 3 4 Besterfields as authors. You can refer to that particular book. You will find some very good examples by which you can understand this particular process. So one, and how to make this particular thing one by one, let us understand this particular concept. Of course, first step is identify who are those particular customers, very important. Once you do this particular thing, the next step comes in, determine the customer requirements. So list down all those requirements on the what's part. Once you do this particular thing, you go to the next step, where with that particular next step you identify how to prioritize those particular requirements. This implies, with respect to one particular customer requirement, how this requirement is related to what kind of a customer. So that basically helps in prioritizing those things. Once you do that particular part, you reach to a level where you identify that, okay, can I actually label these particular things in terms of that what is the current practice. So we are right now in those particular case where we have to identify and evaluate the competition. So see, your particular product can actually give some outcomes if you know what is the existing thing in the market, and then you can actually try to deliver a better product compared to that particular thing. So that particular competition part basically comes on the right hand part. Once you do this particular thing, the technical descriptors and their analysis, that particular thing actually comes into picture. So basically we are working on that particular house part. Once you do this particular thing, you go into a zone where you find out relationship between the what's and hows. So basically we want to find out what is what's and hows. This is that particular relationship type things which I mentioned. For example, a dark circle or a circle or a triangle. It can be even on a negative side. Once you do that particular thing, you reach to a level where the top triangular matrix comes into picture, which is comparison between technical descriptors, that is house versus house. Once you do that entire thing, the step which comes into picture is finding out target. What is that particular specific target which a customer desires? And once you do this particular thing, you are actually at a level where you clearly understand what this particular product should do. So for that, then you create a requirement list. And once you create that particular requirement list, you are at a level where you can start thinking about developing the first prototype. Of course, prototype development will be requiring understanding of the process. It will also be requiring understanding of different parts and components that will be going into it. And then finally, you will be having a first working prototype. If that particular thing is considered for feedback, take that particular feedback, recognize it, go again with the design thinking cycle. And then finally, if everything is good, if you test it and it is working, perfect, you can go for the actual production launch. That's all for today from my side. If there are any queries, feel free to ask me.
Any queries or questions from participants? So it seems there is no question, but there is comment in the chat box that it's very nice presentation and many
And
more.
the comments are the slides are not changing. But the thing is, you basically have sort of an instructor in front of you who do not care about what is there on the slide. So many a times things come straight from the mindset and there is nothing to see.
Yes, sir.
But yeah,
Actually, sir.
that happens in an online interaction.
Yes, sir. Yes, sir. We are sorry for that. Asking you again.
No,
So,
this is an
thank
issue
you, sir.
which happens with Google Meet. Had you used sort of a WebEx kind of a tool,
Yes,
maybe,
sir.
or a Microsoft Teams, so in that particular case, this thing never happens.
Okay.
But yeah, Google Meet is free,
Yes, so
so
that's why we have used
maybe
this.
we can avail that advantage.
Okay, sir. Thank you, sir. It was a really very interesting session, and its participants definitely have got benefited by your talk. And we are very thankful to you, sir, for being expert of this session. And we seek your guidance in future also, sir. Will be your we will be in need of your blessings, sir.
Thank you, Dr. Indu. The pleasure is all mine. And if you want, let's say, any other participant wants any more information with respect to design thinking, with respect to product development, with respect to, let's say, the quality function deployment thing, feel free to contact me. And in fact, I am also giving sort of an open invitation for all of you. We have got some wonderful prototyping facilities which are available at IIT Roorkee, and those facilities are with our tinkering lab. In fact, this is a huge and wonderful establishment that we have. So if you want to actually use some of those facilities, those equipments are available on a portal named as iSTEM. And this iSTEM is a portal which is managed by ISC Bangalore, and it is basically initiative of Principal Scientific Advisor, Government of India. So if any one of you wants to use, let's say, any of the prototyping facilities, feel free to book for that particular thing on the iSTEM portal. You making a user on iSTEM is easy and it is free, so you can use that particular thing. There are certain very nominal charges which are there for some of the equipments, which are really nominal. So in case if you want to use, let's say, even a sophisticated kind of a thing, you will find that the charges are again quite bare minimal. So even in this particular time where we all are affected by COVID, the lab is working fine. So you can use those things. In case if you want, let's say, a sophisticated kind of facility for any kind of a characterization, again we have some of those facilities again listed on the iSTEM portal. For example, FEACM kind of a thing, or if you want to do some kind of an X-ray diffraction or a TIM kind of a thing. So again, those facilities are available and they are available for use for anyone in India. So please use that iSTEM, and you will be happy to know that yes, you can actually take benefit of the resources that IIT Roorkee has. Okay, so thank you very much. Thank you for your time and
Thank you, sir.
patiently hearing to me. Thank you. Bye bye.
Thank you very much, sir. Thank you.
Thank you very much, sir.
Thank you.
Uh, we'll be sharing sir's mail ID and other details on the that WhatsApp group. And dear participants, we'll be meeting back at 2:15 for the next session.